Hi, I'm Biff Turkelman. You see me in such fine quality, epic chemistry educational videos such as Chemistry, What Does It Matter? And Chemistry is for Winners, Part 3. Alright, here's your review for Chapter 2. We're going to go really fast looking at the classification of matter. We're going to have to do this in 2 parts, guys, because I can't finish it. This is a very big chapter. So with that, our first thing is look at the objectives. That will tell you, gives you a clue about what are we interested in. We're looking at matter and its characteristics. We're looking at where did matter come from, how it was created, looking at physical and chemical properties of materials, physical and chemical changes of materials, okay? And then the difference between mixtures and pure substances, including homogeneous and heterogeneous substances. So that's an awful lot. Let us go ahead and get started. So matter, we know anything that takes up space and it weighs something. God created it out of nothing. That's where we get the phrase ex nihilo, meaning out of Latin, for that in Genesis 1. Matter is organized into 2 basic ways. There's mixtures, but there's also pure substances. Okay? So if a substance is pure or mixture, we can look at chemical properties. We can also look at physical properties. Okay? For that. So when we go and we look at something like physical properties, okay, it's something that we can measure without actually changing the material. So we can look at the color, the taste, the texture. Is it a solid? Is it a liquid? Is it a gas? Okay, one example of a physical property is density. Not going to worry too much about that for this test. Okay. Other physical properties, things like can we hammer it into different shapes? How about ductility? Okay. We also looked at conductivity. How well does it allow heat or electricity to pass through itself? Okay. When we talk about the idea of particles, well, in chemistry, we're defining particles, okay, and we'll go right through. Those are atoms, and molecules together. So the word particle, it covers a lot. It's much like a car. A car covers an awful lot. Well, what kind of car? A Mercedes 560 SL, a Ford Mustang, a Toyota Camry, a Chevy Volt. Okay? So atoms, molecules, and atoms and molecules together. Okay? So those when we look at physical properties. Now we look at chemical properties, and how does it react when it's mixed with something else? That would be a biggie, and you got a couple of examples there. And does it change composition if we add enough energy to it? Like gasoline on fire, iron rusting, okay? Then as we move away from physical and chemical properties, the other thing is looking at physical and chemical changes. Physical changes, okay, so physical changes, when we look at it, ladies and gentlemen, okay, there we go. So physical changes, we can look at change in physical properties where the substance remains the same. So here's a great example. If I start with paper and I cut it up into little pieces, I end with paper, is that a physical or chemical change? Well, hey, this is in fact a physical change. On the other hand, when you have a chemical change, you have the substance that changes. A new substance is formed. If I take paper and I burn it, I will now have paper that has been turned into carbon, but I started with paper, I ended up with carbon. Chemical change. Melting a candy bar in your mouth, dissolving it into its pieces. Chemical change. Slicing a telephone book in half. Physical change. Okay? So, that brings us now back to pure substances and mixtures when we look at matter. Okay? So, pure substance consists of only one type of matter, whereas it's a mixture is something that can be separated into 2 or more substances just simply by physical changes. So we can look at salad here is a mixture because we can pick out the different parts, right? We can do that. So in the mixtures, we have two kinds. There are heterogeneous and homogeneous. Heterogeneous, you could look at something that's like a suspension, okay? Think about when you look at the Caesar salad, okay, the oily kind. You have to shake it up. So pretty much anything you've got to shake up, if you're going to use it, that would be a heterogeneous mixture. Chocolate milk, for example, because you have to shake it up, right? Salad dressings, yep, you got to shake it up, right? Exactly. Homogeneous, on the other hand, it's a uniform mixture of two or more pure substances. So we can look at something like milk, coffee, okay? Those are homogeneous solutions there. Saline solution, saltwater solution, glucose solution, where you mix glucose with water, okay? So then now we've looked at mixtures. Now let's go and focus on pure substances. Now there's two kinds. There are elements and there are compounds. Elements, it's only one kind. Compounds, it's more than one kind. So elements, we can talk about, it's pure, it's made up of one kind of atom like gold or oxygen or silver or copper or mercury. Then you have atoms. Atoms that can make up elements. They're the smallest piece of an element that's still that element. We can't take gold, break it down. Oh, I got a gold proton and a silver neutron, and I've got this mercury electron. No. You take gold, you smash the atom, you have protons, electrons, and neutrons. You take a mercury atom, you smash it. You've got protons, neutrons, electrons. If you have a silver atom and you smash it, you have protons, neutrons, and electrons. So all of that, ladies and gentlemen, it's the same. You smash an atom, you get the same basic parts, like the same basic Lego pieces. Yeah. So when you have an atom that has a positive charge or a negative charge, that's what we refer to as an ion, okay? So that's what we refer to as an ion. Now we talked about each element has its own chemical symbol, like B for boron, Ca for calcium, like that, okay? Elements can occur naturally in three possible categories. It could be by themselves, monatomic, think of solo, okay? Ne, neon, Ar, argon, He, helium, that's a pretty common one. Diatomic, meaning two oxygens, two hydrogens together. Then you have polyatomic, where you have O3 and S8. Poly meaning more, three or more. Okay? O3, ozone, O2, they're both made of oxygen atoms. This one has two, this one has three. We cannot breathe in ozone and our bodies will use it. No, because our body is designed to breathe in O2 and use that. Okay? Molecules. So, two or more atoms chemically bonded together. They could be of the same element, atoms of the same element, or they could be different elements. Okay? So I gave some examples here about molecules. Here's a caffeine molecule. Compounds, okay, molecules from two or more different elements that have been chemically bonded together. And then we have the formula. So compounds, when we look at that, think of water, H2O, you've got two elements, two different elements that are bonded together chemically. CO2, carbon dioxide, that is also two different elements bonded together. And that's what we call a compound. A formula tells us the number of atoms of each element that's present. That's kind of important because it's kind of like chemicalese, I call it. Shorthand, like H2O, CO2, NaCl. All those are, in fact, formulas. And they tell us the number of atoms of each element that's present. So we look at the numbers down below here. That's what we call the subscript. It tells us here I have 2 of these FEs, 3 of these O's. And we worked on that in class. You guys worked on a worksheet in class where we worked with that. Okay? We also looked at the coefficient, which tells us how many of a particular molecule that we have. So here it's like Fe2O3. We got 5 of these running loose out there. Okay? So that's a coefficient. And then it leads us now to energy and matter. Okay? And I'm going to stop here for this video because the others, it's going to take a little time to work with those. Okay? All right. I'm Diff Turkelman, and I approve of this video. So long.